Aluminum is actually a better conductor than copper.
But it's not as dense and it doesn't carry as much electrons across it as copper. When it gets down to the smaller wires, it's just too malleable. Even if you have a little nick in the aluminum, that kind of creates kind of like a hot spot. Let's kind of stay on topic of the GFI real quick. Line of load is at the top or the bottom of the GFI. I've seen this problem before where we showed up and customers changed it out and things are not working like how they're supposed to.
Well, it's easy. Just read it.
You have it marked already on your wire. Take a look at line or low, line low, line low, whatever. Put in that.
If you're replacing your LGFI and you kind of understand enough of what we're talking about, when you take out an existing GFI, be sure to pay close attention to your line and load, because hopefully you're turning the power off before you're changing the device. And if power's off and you don't pay attention to which one is on the line portion of your GFCI and the load portion of side of your GFCI, then you're going to have a hard time determining which one's your line and load. Now, you have to go out, turn the power back on, test which one is your line. But just to keep it simple, when you take it out, just identify it before you actually remove them from the old device.
Should you test it again, even after you turn it off?
You should always test anything you're working on electrical. Once you turn it off, they'll never take for granted that it's not. Well, breaker could be mislabeled. Or somebody could have done some wiring around that area that you didn't know about, and maybe that's not part of the circuit you think it is. So
could be two circuits in a box.
Could be two circuits. If you're sharing a neutral, you still have the potential of having electricity on your neutral, because a neutral is a load carrying conductor. I've learned this when I was an apprentice, because back when I was wiring production homes, it was very common to share neutral wires and wiring track holes. So if you turn the circuit off and you were working on that circuit and someone's running a tool or there's an appliance running on that circuit somewhere else, you get electrocuted, you get shocked by that neutral wire. And as an apprentice, you're going, what the heck? I turned the power off. I recommend homeowners doing work. They should just turn the main off or turn all the circuits.
Just shut everything off.
Shut it off to be safe.
There was an electrician that said that when you start opening up things and you have doubt, or you have one little smidge of being uncomfortable doing that, call a professional.
I'm going to say no. Simply because when you're working in a box, you shut the power down. You're assuming there's no other electricity in the box.
I feel it should be on a 2-pole. I think if there's two circuits in one box, it should be on a 2-pole.
Let's look that up, because I'm curious what the actual answer is for that. Because it's not something we run across it a lot, and I think it's a common practice where people will run two circuits to a box. Most commonly is you have a 3-wire running to a box and you're sharing a neutral. Kitchens used to be very common. You would split that off for a dishwasher disposal, one off for appliance circuit, share the neutral. That was very common in those days. It was never an issue. I think there is a situation where it's an illegal application. All that circuits that are sharing the neutral need to be on a 2-pole circuit. So you shut one off, by default, you're shutting the other one off. And I think it depends on the box. I mean, obviously, you have a screw in a junction box, you have more like a regular J box. You're going to have more than one circuit in there where you're splicing. Maybe you're relocating some circuits, or even in your main panel. You have more than one circuit in there, obviously. I'm thinking more like a switch junction box or a plug junction box. As a good electrician, you should know to check for that. But I think I'm thinking what homeowners are working within their homeowner. If they're working on their own home, and they're pulling something out, they don't know what to look for. That could be dangerous.
Let's say if you have a 3-gang with 2 switches that does this lighting, it's part of this side of the circuit. And then you have another hallway light that is a 3-way from another circuit, and you run it to that location. You have 2 circuits right there in a 3-gang box.
No, you could. I mean, most commonly, like I said, it's probably when you're splitting circuits off of a 3-wire install, but if you could. My concern with that is if you have 2 circuits running there, now you have potential of 240 volts. So if you got 2 lines running out there and they're both live, it's a tough one. But the code says it's okay. Again, if you're a qualified electrician, you understand how to test, you know what you're looking for, it's not an issue.
I always check if I shut down that circuit right there, it's a 3-gang or 4-gang box. And I go in there, I'm like, oh, this side is still hot. Well, let's not touch this side. We're working on this side only.
Use your voltmeter. Don't use the dummy stick. I call them the dummy sticks. The testers are great. They can kind of give you a good idea. There's voltage there, but find out if it's actual voltage on your load. Make sure it's actual voltage. Yeah, that should be there or shouldn't be there.
I tend to somewhat agree but disagree with that, because that sniffer is my first line of defense, where I'll I'll actually sniff and I'll go, okay, is that hot?
No,
Let's check it. And then I pull out my meter and check it. Oh, it's just a bleed over signal from wherever.
that's fine for your first line, but it's still just double check it.
Yeah, always double check.
And they're not always right.
Yeah.
We used to use them. We use them when we're demoing stuff a lot. So when you're going checking out wires, so you can cut them.
I think a good example of that was I was working on a circuit and I shut it off, and I actually showed the apprentice, and I was like, all right, this circuit here is shut off right now. And I got my sniffer and I put it on that circuit and it beeped. And I'm like, all right, why is this circuit still hot? He's like, I don't know. And so I grabbed my multimeter and I tested that circuit, and it was reading, I think, like 4 or 5 volts. And I was like, how come we're getting 4 or 5 volts? I actually knew the answer already. And he's all, I don't know. Is it something shorted to it? I'm like, well, in that panel, when that circuit comes out, there's a bundle of home run. And those home runs right now are still energized, and it's creating a magnetic field. And that magnetic field is actually pulling the electrons in the wire that is dead right now. And I was like, go and shut off everything. And we went and we shut off everything, and I got measure the voltage of that now, and measured it, and it's like, there's nothing there. And he's like, holy smokes. I was like, wireless charging? That's how it works.
Anytime you're trying to sniff out a hot wire around a lot of other hot wires, sometimes that field can give you a false reading. That's why I was just a fan using your voltmeter. We're testing systems continuously, and we learn over time. So when they started knob and tube wiring back in the 40s or 50s, they actually transferred around 1950, right around that era. We were running more of a load on houses. We had more demand. So we had to change that method, and then we started using power tools and different equipment. We combined the knob and tube, your neutral, your hots into one sheet. So now it became more efficient. So a lot of it stems being, to efficiency. We can get it done quicker. We can build more. We can charge less. We can make cost more, or cost effective. And they find that certain materials don't last as long as they've hoped they would. So they use a different material, hope it'll last longer. Then another 20 years goes by, and then they realize, oh, this is wearing out. You've got the different types of wiring, right? You've got your sheeting, you've got your insulation around your wires, you got your knobs, you got your tubes, but there's one thing that just really doesn't stop doing its job. Really doesn't. This is my opinion anyway. Copper never fails. Sure, it might become unsafe because it's not protected adequately, or the connection might have failed, or the insulation on the wire might have failed. But copper is still a good conductor. 100 years from now, it's still a good conductor. The flip side of that, what do you think of aluminum wiring?
I'm not a big fan of aluminum at all.
What was the dates that they started using aluminum? I don't know roughly, but I know I've seen it in the upper 60s and up through probably even the early 80s, maybe.
It was during the metal shortage, like during World War II and stuff. And so companies also wanted to go cheaper too. So they actually started using aluminum. And it's crazy because number 12 aluminum is only good up to 15 amps. But number 12 copper is good up to 20 amps, right?
Aluminum is actually a better conductor than copper.
But it's not as dense, and it doesn't carry as much electrons across it as copper. That's a big thing. When it gets down to the smaller wires, it's just too malleable. Even if you have a little nick in the aluminum, that kind of creates kind of like a hot spot,
right?
Because you actually, it's like having a freeway, and then somebody just comes by and takes one lane out for 10 feet or whatever.
It doesn't handle heat as well. So I think the most fails, where aluminum fails the most, is at every point of a junction or a connection point. So whether it be a wire nut or a mechanical connection, it expands and contracts a lot more. It gets most out. So it loosens up those connections, builds oxidation, and builds heat trying to transfer the energy, and therefore we have a fail. So that's where there's a lot of fires in homes that are wired with branch circuit aluminum wiring. Branch circuit meaning your plugs, lights, and appliances. Now I'm okay with aluminum wiring for subfeeds like sub panels. Utility companies use aluminum wiring for your main panel services. It's lighter, more cost effective, and there's only 2 points of connections on that. You have a connection at a transformer usually, and a connection at your actual panel. And they're heavy duty aluminum connections, and they use a material called Nolox. It's a corrosion inhibitor that helps keep the that connection from oxidizing to get hot.
It takes out the pyramid.
Yeah.
one of it takes out.
As far as aluminum wiring branch circuitry, I mean, that's why they don't use it anymore.
Yeah.
It's not legal to use anymore unless you're using it for subfeeds.
And plus with aluminum, like let's say if you have it in the panel, gosh, you would have to have your lugs in your panel for the grounding, for the neutral, and on your breaker to be basically redo at least every couple years, because maintenance, you have to have maintenance. I mean, even with copper too, you still need maintenance, but with aluminum, it's one of those like ticking time.
You have a house that was wired with your plugs and lights wired with aluminum wiring. Maintenance would be critical. It's an exhaustive maintenance program. I think if you want to really make sure they're safe, you're going through every device and checking all of those connections, not just at your panels. You're actually looking throughout the house for those.